So risk will be less when you are at the age of say 25, 23, 24. Equal interval binning or grouping or categorizing, and equal frequency binning. Better categorization. We get 662 values. Most values will be considered in the each category. Owner with parents and others, or you can have owners, renters and others. Hello students, welcome to the next session of Cloud Computing and Big Data Analytics. I am Dr. Soumyashri from Department of Computer Science, Vidhyaashram, First Grade College. Let's start this session. This session is all about knowing the categorization of the big data. How do you categorize the big data in the analytical process? Let's start this session. The thing is, the categorization, which is also known as coarse classification or roughly classifying the data, or classing or grouping or binning, everything is same, can be done for various reasons. What are the reasons that we consider the categorization is? For categorical variables, it is needed to reduce the number of categories. You have to reduce the data to minimum number of categories. With the process of categorization, one would create categories of values or groups of values such that fewer parameters will have to be estimated. You have to consider as minimum data as possible to analyze the data. You have to first get only minimum set of values or minimum range of values for estimation. And a more robust model will be obtained which gives you a proper and accurate data when compared to the unscrutinized, uncategorized raw data. Okay, so we have the categorization for continuous variables. It may also be very beneficial. You will get only minimum ranges for continuous variables. Consider, for example, the age variable and its risk as is depicted in this picture. We have the default risk versus age. What is the number of risk with the age? Sometimes it will be risk will be more in 16th age, maybe minimum as you continue with the same values or continue with the ages. So risk will be less when you are at the age of say 25, 23, 24. At that range, the risk will be little bit less. When you cross 30, the risk again increases, maybe related to the life risk or the security risk, whatever it is. The risk goes on reducing with the age. So we have these continuous variables. These are the different variable ranges. So we have different variables. These are continuous variables. Categorization of these variables will be very much helpful for analyzing the data in the big data environment. Okay, so clearly there is a non-monotonous relation. It is not unidirectional. It is a non-monotonous. It is a different or varying relationship between the risk and the age. It is neither decreasing nor it is increasing. It is non-monotonous. It is not monotonous. It is always changing, isn't it? So, if a non-linear model like neural networks or the decision trees are considered, if in a non-linear model were to be used with these continuous variables, then the non-linearity can be perfectly modeled. If you are using the non-linear model instead of regression, if you use the neural network, decision trees or the support vector machine, you can have non-linearity model built over the set of values. However, if a regression model has to be used for minimum range of values, which is more common because of its interpretability. You can easily interpret the values in the regression model. But in decision tree and other non-linear models, it is not very much easier. So, it is used more commonly, regression model. Since it can only fit a line, it will miss out on the non-monotonicity. That means it will not be able, the regression model will not be able to calculate the range of values with non-monotonous variables. Like if you say this is not a straight line, neither decreasing nor increasing. Regression models are useful only when you have straight lines of graph. When you have straight lines either in a decreasing manner or increasing manner, you can easily categorize the data using the regression model. But it is not possible with the non-monotonous values to apply the regression model. Then how do you categorize? Why do you categorize is by categorizing the variable into ranges, different ranges, part of the non-monotonicity can be taken into account in the regression. You can have a wide range of values in a regression model if you take more range of values in the big data. Hence, categorization of continuous variables, considering the continuous variables can be useful to model the non-linear effects into linear models. Non-linear effects will be applied to the linear model, which will take more range of values, which will be useful for categorizing these values. Alright. So, there are various methods that can be used to do the categorization. How do you perform the categorization? How do you group the values? There are two very basic methods that are having these facilities. We have two methods. One is equal interval binning or grouping or categorizing, and equal frequency binning. Binning is nothing but categorizing, simply. So, equal interval grouping and equal frequency grouping. We use these two methods for categorizing the values. Say, for example, if you take the income values are 1000, 1200, 1300, 2000, 1800 and 1400. We have these non-monotonous values for the each. There will be equal interval binning or grouping would create two bins or two groups or two clusters with the same range. That is, the bin 1 or the cluster 1 will have 1000, 1500 and 2000, and bin 2 can have 1500 and 2000, whereas equal frequency binning would create two bins with the same number of observation. There will be frequency of binning with same number of observation. That is, bin 1 will have 1000, 1300 and 1200 and 300. That is one range of values. Bin 2 will have 1400, 1800 and 2000. Based on certain parameters, there will be clustering or categorization of the data which are non-monotonous. But both methods are the basic one and do not take into account a target variable, which is not a legitimate or valid observation or valid kind of data. It does not consider the target variable or invalid data. So, what we can do? We can use an analysis method known as chi-squared analysis. Chi-squared analysis is a more sophisticated way to do the coarse classification or the clustering or grouping of the data. Consider an example that is given in the table for clustering or coarse classifying a residential status variable. Okay, in a residential complex. Say we have the attributes good, bad or odd you can take. How many number of owners are there? Rent unfurnished, rent furnished. With parents, how many are there? Others, no answer, none of them given, no answer has been given. And the total number of members will take the ratio of good and the bad odds. Okay, so we have bads, that is how many are good category or how many are bad category. We consider the housing society or a residential status variable we consider. How do you categorize this? So you can categorize in this manner. Okay, suppose we want 3 categories. We have to reduce it to 3 categories and consider the following options. So option 1 is, this is owner, renters and others. This is one option. Or you can have another group, that is owner with parents and others. Owner with parents and others. Or you can have owners, renters and others. So you can have 2 options. Both the options can now be investigated using the chi-squared analysis. You can perform a chi-squared analysis which considers the independent variables or independence of the variables from other variables. The purpose is to compare the empirically observed independence frequencies, how much they are independent from other values. For option 1, the empirically observed frequencies are depicted as in the table, owners, renters and others. We have the empirical frequency. We have the 3 categories now, 6,000, 1,950 renters which are in goods category and others 1,050 in goods category, total 9,000. So they are more independent now. Owner is more independent, renters we have and others. So there will be empirical frequency of option 1 for course classifying the residential status. You can consider the independence of variables. So for deciding the independency of the variables, we consider the chi-square analysis. Okay. Then the independence frequencies can be calculated as follows. How do you calculate the independence frequency? Independence frequency is the number of good owners given that the odds are the same as in the whole population. Considering the number of good owners given that odds are the same. Odds will be considered as the same that of good owners is 6,300 divided by 10,000 into 9,000 divided by 10,000. That is total it is considered. Into 10,000 equals 5,670. So it obtains the table for which the more the number in the both tables differ, we have 2 options. As the values in 2 tables differ, the less independence the values will become. Hence, better dependence. Less independence means they are dependent on other values, and a better classification or categorization can be done by using the chi-square analysis. So, less independence makes it dependent on the other values, which takes a good categorization method. So, to formally one can calculate the chi-squared distance using this expression. So, what is the chi-squared expression is or chi-squared distance is? So, we use these values to calculate the chi-squared distance between the different values. So, the average or chi-squared distance is 583. Okay. The next thing is, likewise for option 2, the calculation will become like this. So, this is the calculation we consider with the value 662. Okay. Based upon the chi-squared values, Option 2 is the better categorization. We get 662 values. Most values will be considered in the each category. So the average members that comes into a group or categorized will be 662. That means there will be less groups and more numbers. The option 1 is 583. That means there is less number. When compared to the option 1, option 2 of kind of categorization is better based upon the chi-squared values obtained. Okay. Note that formally or officially, one needs to compare the value with a chi-squared distribution with k minus 1 degrees. You have to compare the values with the chi-squared distribution, how the values are distributed with k minus 1 degrees of freedom. What is k? K being the number of values of the characteristic or a variable. How many number of values are there in the variable? Based on that, one less than that distribution will be done. If you have 5 variables, there will be 4 chi-squared distribution that will be made with the average group members or group values. Okay, so we use this value. There are many analytics software tools that have built-in facilities to do categorization. We have so many tools that can built-in facilities to do the categorization using the chi-squared analysis. You can use these categories or analytical software tools to categorize the values based on the chi-square analysis. The simple and handy approach that is available in Microsoft Excel for getting the categorization is the pivot tables. So what does the pivot table will do? So the pivot table categorizes the values based on different conditions. So this may include the sum, averages, or the date. So based on different conditions or different set of values, the values that are entered in the Excel sheet will be categorized, which can be considered as a pivot table. So we can consider these pivot table for the categorization of the data in case of big data, whether it is comfortable or whether it is usable with the big data. Yes, it is usable with the big data. You can easily use these data to categorize the values using a pivot table. So this is about the method of categorization, how you are going to categorize the values in the big data analysis. So first thing is you have to structure or unstructure the data, divide the data into different categories, that is structured or unstructured data, and then you have to pre-process it. So pre-process will include cleaning of the data using the different methods, then the selection or outlier detection, that is selecting only set of values, outlier detection and treatment, treating the missing values. How do you deal with the missing values? Whether you are going to deal it, whether you are going to keep it, all these things must be considered. Then once you get the range of values, leaving the outlier values, you have to standardize them for a range of values, isn't it? So that comes under the standardization. Once you standardize it, you'll get another range of values. The standardized data now should be categorized. So how do you categorize this? Based on different values, isn't it? So you can consider the analysis using a chi-square or a pivot table. You can use any of the method to categorize. So less groups will make much more comfortable categorization. So this is all about what you can learn about the categorization of the data. Thank you.